right. Today for Algebra 2, I'm going to be working with looking at parabolas. So we've worked with parabolas throughout this semester, throughout the school year, and we've done a lot with, may have done work with parabolas in Algebra 1. We're going to be looking today at parabolas in a slightly different context, looking at how how we can rethink looking at the equation of parabolas in kind of a slightly different way. Okay. So first, let's do a little bit of review of what a parabola is and how the equation works. And then I'm going to get into the new stuff we're going to work on, which is looking at two new things about parabolas, which is that every parabola has an imaginary point not on the parabola called a focus. We'll talk about what the focus represents and how it works. And every parabola has an imaginary line associated with it called the directrix. Okay, so first of all, for right now, I have here on my screen the graph of a parabola, and this is simply the graph of y equals x squared. Okay, and remember, this is how we get a parabola. A parabola is a graph of a quadratic function, meaning a function where x is being squared, and our base function for a parabola has a point called the vertex, which is at 0, 0. And in this case, it's a minimum value. The parabolas we're going to be working with today, for the most part, are going to have that focus or that vertex at the origin at 0, 0. We may look at towards the end of the time today, may look at some things, some parabolas that have, and how we can translate them, how we can move them. But for now, we're going to leave it here. So let's talk about this specific parabola. Okay, this parabola has a focus, okay, at the point 0, 1/4. And I'm going to zoom in here a little bit. Okay, and it has an imaginary line called the directrix at y equals -1/4. Okay, the focus and the directrix have some kind of cool properties associated with them. Okay, so a way that we can actually define what a parabola is and what that shape is not just that it's the graph of the equation y equals x squared, but it is also the set of all points that is equidistant from a point called the focus and a line called the directrix. Okay. And so what that means is that for this parabola, and I'll get to in a little bit why its focus is at this particular point and its directrix is this particular line. But what you need to know now is that I can pick any point on this parabola, and its distance, for instance, if I pick this point, the point 2, 2 that is on the parabola, okay. If I draw an imaginary line straight down to the directrix and draw another imaginary line connecting it to the focus, those two lines are going to be equidistant. Okay, same distance. Right? And it's going to be the same if I choose any other point on the parabola. Okay. So the way we find, if we know an equation for a parabola, the way we find the focus and the directrix is I'm going to show you a different parabola. So this parabola, I now have the equation y equals 1/4 x squared. This parabola, now as you can see, it's a little wider than the original parabola. If I show them both together, you can see the first parabola narrower, and also its focus and directrix are closer to it. Okay. So this new parabola, a little bit wider, which means it's been vertically it's been shrunk, but the focus and directrix are further away. And I like this parabola because it's pretty easy to see that one of the points on the parabola is the point 2, 1. Right? And I'll just plot that point here on the screen. Okay, so you can see that point 2, 1, and that point is 2 away from the focus. It's also 2 away from the directrix. Right? And so you can see, oh, it's the same distance away, and that's going to be true of any other point. Now, we're not always going to get those perfect vertical and horizontal lines, so it's not as easy to see, but that is the case. Okay, every point on a parabola, if I measure the distance from that point to the focus, the distance from that point to the directrix is the same. Okay, so I've got another graph here that shows us a little bit more clearly. Okay. So here you can see I have now a parabola, and I'm going to make this a little easier to see. I have a parabola, and I have now drawn in the parabola, the focus, and the directrix, and I've got these lines drawn too that connect a point on the graph to the focus and the directrix. Okay, and no matter where this point goes, when I drop on what we call an altitude, so that's a line straight down that's perpendicular to the directrix. Okay, it's the shortest distance from this point to the directrix. So when I draw that, and when I draw the line that connects the point to the focus, no matter what point I choose on the parabola, those lines are always the same length. And there's a little bit of math involved here, but I actually calculated out what the distances are, but both the distances are equal. Okay, and as I move the point on the parabola, those distances are the same. Okay, and if I get the point right there, you can see that they're going to be they're always equal. So that's kind of a cool thing. Now, so that's why the focus and the directrix are important. Okay, is that they give us this new property when dealing with parabolas. Okay, and that and now we can define a parabola by, oh, it's this set of points that's always has the same distance from the focus and from the directrix.